Hello, and welcome to part 1 of my multimodality video series. I'm Jennifer Marsman, and today we'll take a look at how OpenAI's GPT-4 works and how I'll be applying these capabilities to solve my Wordle woes. What I want to do is, instead of like I typically do, where I start with a perfect solution, we're going to start all the way back with Hello World and walk through each one of the steps that I tried to try to make this problem work. Let me start by giving you a very quick introduction to what GPT's visual capabilities are. So if you want to utilize the GPT-V model, this model is available with the model name GPT-4 Vision Preview today, but the V actually does stand for visual capabilities. So with this model, you can input both text and an image, and then ask questions in your text about that image. The model does not receive any image metadata. So if you want information about the file size or information that is in the file name, that is not possible. It does support a variety of different well-known image formats, PNGs, JPEGs, etc. There is an image upload limit of 20 megabytes per image right now, no fine-tuning to date, and some of the other things like the function and tool support, the response format parameter, which allows you to format output as JSON, and some of those other things that were released at OpenAI's Dev Day back in November 2023 are not yet supported in the visual model. But all of these things are subject to change. This was current as of November 2023. It's actually still current today. But things can still change. All right, so let me walk you through a few very quick scenarios on what the visual capabilities can do, and then we'll jump into the Wordle problem. But in case you haven't seen GPT-V before, here's some of the things that we can do. We can give an image of an outfit. And of course, remember, your mileage may vary. I'm not saying this would work with any outfit, but we did find an outfit and asked what dress is she wearing, and the model correctly was able to tell us that this came from the Gucci Spring 2016 Ready to Wear collection. And I had to go look that up because I did not know, but it was in fact correct. There's some sports analysis scenarios. So I asked, what is wrong with the skier's form, looking at kind of the angle of their legs there relative to the hill. And the model is able to give a fairly good answer on what is wrong with the skier's form. There's a circuit diagram image, and we ask, will the lamps in this image work? And the answer I was looking for was really the first answer that was given there, that the circuit was incomplete. But it actually came up with two other reasons that, after reading them, made sense. Number 2 is really more of a best practice, saying that the lamp should be connected in parallel rather than in series. Yes, if they are in series like they are right there, if one goes out, they will all go out, much like holiday lights that you put up. But that's more of a best practice. It's not strictly necessary. And then the last one is that the battery may not have enough power, which is also a legitimate thing to consider there. So very interesting analysis, and the fact that it thought of things that I wasn't thinking of was neat. All right, scene understanding. So there's some really amazing work that's being done by the Seeing AI team at Microsoft that's run by an engineer who is blind. And they do a lot of work, and there's a free app called Seeing AI that's available on iOS and on Android that will allow you to do common tasks that may be needed by the blind and low vision community. Things like pointing your cell phone at perhaps some currency, some money, taking a picture, and then asking how much money is this, if there's bills that are the same size in your currency. And it can do things like that. So I tested it on a couple scenarios that may be relevant. I did take a picture of my pantry, which obviously means that Jennifer's kids eat way too much sugary cereal. But when asked, it did correctly identify the 3 types of cereal that were in there. And it also noticed that there was it's actually a box, not a bag, but it did notice the Triscuits in there as well, even with occlusion. The T was cut off of Triscuits. So that was kind of neat. And then again, thinking about the blind and low vision community, I tried an example where I asked, what was that noise? And in this case, there is an image of a train rumbling past here. And it did say that it recognized a large rumbling noise that was likely a train. And then it mentioned the wooded area as well. So pulling out some other details about the image. I also have a couple of color tests here. We're gonna come back to this. So remember this for when we get into the Wordle later on. But I wanted to ask about a non-Roy G. Biv standard color. So I looked up the hex value of coral, of the color coral, and made a little image in Paint, and then asked what color is this, and it correctly identified it as coral. And then I have an image of someone getting married and a bunch of bridesmaids around her. And I ask, what color are the bridesmaids' dresses? It's able to identify them correctly as red, the bride's dress as white, and the kind of flowers they are carrying correctly. Now, so it is able to identify, pieces within the image. Things like a bride's dress being white, one could perhaps argue that if this was trained on mainly, Western culture data, that perhaps it could be pulling that from training data, as Western brides typically wear white on their wedding day. But again, there are those things to keep in mind, but it does, in fact, pull the answer correctly here. And then finally, I wanted to show an example of handwritten text. I love this example because it really combines 2 different things here. We need to do both the OCR-like capabilities of extracting those words from the handwritten text and understanding what's said. And then I'm also asking to summarize this letter. So not only do we need to kind of read the text, but then I need to apply a summary to it as well. And if you read the summary, it actually does a fairly good job. And I will call out, I did look up Alexander Hamilton in Angelica's letters, if you've seen the musical Hamilton. And this is not Angelica's actual handwriting. This was Jennifer Marsman's handwriting, copying it onto a handwritten card. But I did look up the actual text, and I did pull snippets from the actual text between Hamilton and Angelica. So I wanted to try to apply this to the game of Wordle. So this is a game that's now owned by the New York Times. So if you go look to it, you can find it under the New York Times Games. The way it works is that there is a new Wordle word every single day. So it switches over every 24 hours. And the goal is just to guess a 5-letter word. And the thing that makes it a little tricky is that each guess must be a valid 5-letter word. So if I think that there is likely, a W, an X, and a Z in the word, I need to find a word that has all of those legitimately in it to test and see if those letters are really in it. I can't just put in a series of random characters. And then every day you have 6 tries to correctly guess that 5-letter word. Now, after you enter a word, the text, the fill behind each letter will change colors. And if it changes to green, that means that you've guessed the correct letter in the correct position. If it becomes yellow, that means that the letter is in the word, but you don't have it in the correct position. And if it turns dark gray, that means that the letter is not in the word. So we see examples of that here as well. All right. So why Wordle? Why did I choose that of all examples? Other than the fact that Wordle was this little spot of joy during COVID, as we were all, the world was going crazy, but you had a little puzzle to solve every morning when you had your 5 minutes of, this is fine. So the reason that I chose Wordle is actually because it needed an interesting combination of both visual knowledge as well as knowledge that involved like the high semantic understanding that the GPT models have. And so combining those two is really where GPT-V shines. And then the other thing that was interesting to me is the fact that you needed a lot of actually multiple types of kind of pretty tricky visual knowledge. And that can be tricky if you want to do it like all in one pass of the model. So specifically, I need 3 different things when I'm trying to parse the feedback from a Wordle puzzle. I need positional knowledge because I need to know which character is in which position. I need OCR type capabilities, so I need to be able to read each character from that image. And I need to know the knowledge of the colors to identify if they're actually in the right spot or not. All right? All of that visual knowledge plus the logic to give me the rules of the game. And the positional aspect in particular was interesting to me because that is a known hard challenge with these large language models that can do image capabilities. So in all the early testing I've done with multiple image models, that's something that's consistently been tricky. And so because it was so important to this game, I was like, all right, let's see if we can do it. Plus, it's fun, right? It's an interesting problem, so it'll keep your attention and make it easier to learn some of the prompt engineering techniques that we're going to go through. All right, so let's also discuss the limitations of this model. So this was actually pulled straight from OpenAI's website. They have a vision link that is available that goes through these limitations. There's a number of things here. I'll leave the most of this as an exercise for the reader. But the one thing I do want to call out is that spatial reasoning is actually a known challenge here. So the model, it explicitly says that the model struggles with tasks requiring precise spatial location, such as identifying chess positions. All right, so what we are going to try to do involves exactly that kind of logic. So this may be tricky is what I'm trying to say here. So let's see if we can do it. All right, so to begin, let's do the hello world of the GPT vision model. And what I consider the hello world when you're working with these image understanding models is you pass in an image along with the text, describe this image, or what is this? That is the hello world of these models. And so I wanted to start there just to see, did it even recognize this as a Wordle puzzle? Like, was there Wordle information in the training data? Just to get a sense of like where I was starting from. This is where I started. So I passed in the image that you see on the right-hand side of this slide. And do notice that this image was actually cropped. It looks like it's in a cell phone layout here, but it was actually from my laptop, and I just cropped out the sides, the white space on either side to make it fit on the slide a little better. But just to be very transparent about what I was passing in there. And note that the model does recognize that this is a screenshot of a Wordle game in progress. It knows what Wordle is. It gives a quick definition here. It is able to correctly pull out all 4 words that I guessed here: rates, climb, phony, and fudge, which is a good strategy, by the way. If you are looking for a Wordle strategy, that is very good because it covers like the majority of the alphabet within those letters. But notice too that it did actually get some stuff wrong as well. So taking a look, the elements that I've highlighted in yellow are incorrect here. So notice that it says on the first thing that none of these letters are in the correct spot, and there is in fact a green E, so that's not correct. It got the L and the I mixed up essentially in the second word. So it says L is in the word but not in the right spot, but in fact that's the I, which is right next to it. The word phony was guessed. It says that O is in the correct spot, and it is not. But note that right below it is a green character. So again, it may be difficult for the model to recognize colors in a very specific location, because this isn't just recognizing colors. This is very localized color recognition that we're asking for. And then finally, it says that fudge was with no correct letters. And in fact, a D and an E were correct here. So we have our work cut out for us. So this is our starting point, and let's see what we can do. I hope you enjoyed learning a bit more about GPT-4 and its potential use cases. Next week, I'll share how to prompt this type of model to get the information we need.